Hey Ram Bombers, it's Miss Morel, and today we're going to be talking about unstable nuclei and the radioactive decay. So our goals for this is to explain the relationship between unstable nuclei and radioactive decay, characterize alpha, beta, and gamma radiation in terms of mass and charge, and then just a reminder of review vocabulary of what an element is, which we learned in chapter 3. We'll have some new vocabulary. And then the main idea of this section is that unstable atoms emit radiation to gain stability. So, radioactivity. This is nuclear reactions can change one element into a whole nother element. In the late 1890s, scientists noticed some substances spontaneously emitted radiation, and this was a process called radioactivity. The rays in particles emitted are called radiation. And a reaction that involves a change in an atom's nucleus is called a nuclear reaction. Nucleus, nuclear. That kind of makes sense. So unstable nuclei, they lose their energy by emitting radiation in a spontaneous process called radioactive decay. And unstable radioactive elements, they undergo radioactive decay, thus forming into non-radioactive, more stable elements. So alpha radiation is made up of positively charged particles called alpha particles. Each alpha particle contains 2 protons and 2 neutrons, and so in turn, since it has 2 protons, which are positive, it has a +2 charge. So below we see this figure here, and so it shows us how this radium-226, so that's how much it essentially weighs, protons plus neutrons, and its atomic number is 88, and so that's how many protons it has, loses 2 protons, and so it becomes radon, which has a new weight, and it has less protons. So we can see here it becomes radon. So, and then plus the alpha particle, which is the same thing as helium, which we can write helium-4, or we can write an alpha particle. And so here we can show that it essentially is not a loss of mass because it's balanced out because the alpha particle weighs exactly what is lost here. Beta radiation is radiation that has a negative charge and emits beta particles. Each beta particle is an electron with a -1 charge. And so here we can see how carbon-14 becomes nitrogen-14, and it also includes a beta particle. And then gamma rays are high energy radiation with no mass because they're neutral. And so they usually accompany alpha and beta radiation. So here we can see uranium becomes thorium, and then there's an alpha particle and gamma rays. So gamma rays account for the most of the energy lost during radioactive decay. Because gamma rays, they're massless, they don't weigh anything, the emission of gamma rays by themselves, they cannot result in the formation of a new atom. Atoms that contain too many or too few neutrons, they're not stable, and so as a result, they lose energy through radioactive decay to form that stable nucleus that they're always seeking. A few exist in nature, but most have already decayed to already stable forms. And that's all we have for today. I hope that's helpful to you guys. Take good care. Let me know if you need any help. Have a good day. Bye, Brand Bombers.